afternoon, all.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Yeah, thank you. So, boiler part is already completed. Today, we are going to start the third module, IC engine. Okay. So, today we are going to start the IC engine. So, basically, IC engine means it is the short form. The IC engine means the internal combustion engine. Okay. So the internal combustion engine is also called IC engine, or somewhere it is called also ICE. So basically it is a heat engine in which the combustion of fuel occurs with an oxidizer, usually air, in a combustion chamber. That is the integral part of the working fluid flow circuit. So the in an internal combustion engine, the expansion of high temperature and high pressure gases produced by the combustion applies direct force to the some component of the engine, and the force is applied typically to the piston, turbine blades, a rotor or a nozzle. Okay, so this force moves the component over a distance, transforming the chemical energy into a useful work. So basically we this is the general function of the internal combustion engine. So we will go in depth of these IC engines. So first is the introduction. In basically, I told you the IC engine or ICE or the internal combustion engine is a heat engine. So before understand the IC engine, we have to know the heat engine. What is heat engine? Okay. So heat engine is a machine which converts heat energy supplied to it into mechanical energy. Okay. That means it converts heat energy to mechanical work. Okay, that's why I told you that there is inside the internal combustion chamber, there is a internal combustion engine, there is a chamber where the combustion take place. Okay, that means the heat energy is generated, and this heat energy is converted to the mechanical work. Okay, so this heat engine is supplied to the engine by burning of the fuel. So after the burning of the fuel inside the combustion chamber of this IC engine, this heat energy convert this energy to the mechanical work. So basically heat engines are of two types. One is the internal combustion engine, IC engine, or another is the external combustion engine, EC engine. So basically from its name itself you can understand the internal combustion engine, that means the combustion take place inside it. Okay, so the in IC engine, combustion of fuel take place inside the engine cylinder, so that's why it is called internal combustion engine. And external combustion engine means it combustion of the fuel takes place outside the working cylinder. That means the combustion chamber is outside of the external combustion engine, and after the combustion from the outside combustion chamber, the heat is transferred to the inside of the EC engines, and then it converts the heat energy to the mechanical work. Okay, so the example of internal combustion engine is the diesel engine, petrol engine, gas engine. So our cars, those are the used internal combustion engine also. And external combustion engine is the steam engine, steam turbine. So steam engine, steam turbine, that means you can understand from its name that the boiler is there. So steam turbine, so we heat is generated in the combustion chamber of the boiler. Okay, So the heat is generated inside the combustion chamber of the boiler, then the heat energy is taken out from the boiler to the external combustion engine, and the heat energy converts to the mechanical work. Okay. So if we want to know that the basic difference of this external combustion engine and the internal combustion engine, so as I told you that the in the external combustion engine, combustion of air fuel is outside the engine cylinder, and in case of the IC engine, the combustion of air fuel is inside the engine cylinder. In case of the external combustion engine, the engines are running smoothly and silently due to the outside combustion. But in case of the internal combustion engines, this is very noisy and noisy operated engine, because the combustion take place inside the engine itself. Okay. uh, in case of the external combustion engine, we can use cheaper fuels like solid fuels also, because we do the combustion outside the engine. But in case of the IC engine, the high grade fuel are used with proper filtration, because the fuel is used to combustion inside the engine. So high grade fuel with proper filtration is used for the internal combustion engine. The efficiency of the external combustion engine is very low than the internal combustion engine, approximately 50 to 20%. But in case of the internal combustion engine, the efficiency is about 35 to 40%. Okay. In case of the external combustion engine, the water is required for the dissipation of energy through the cooling system. But in case of the internal combustion chamber, the less amount of water is required. And in case of the external combustion chamber, the high starting torque. But in case of the internal combustion chamber, are not self starting. Okay, we have to start it. Okay. So these are the basic difference of the external combustion chamber and the internal combustion chamber. So in here we have to know about the internal combustion engine. Okay, that means the IC engine. In this module you have to know the detail of this internal combustion engine. So basically, the in case of the classification, if we see the classification of internal combustion engine, this is classified on different parameters. So the first parameter is the cycle of operation, number of stroke per cycle, 2-stroke engine, 4-stroke engine. We have to know it in detail. If we use the parameter as the method of heat addition or the thermodynamic cycle, then three types of IC engines are there: Otto cycle, diesel cycle, and the semi-diesel cycle. If we see the use of the fuel, so based on this fuel used, we can divide it in the three types: petrol engine, diesel engine, and the gas engine. In case of the ignition method, two types of are there: spark ignition and the compression ignition. It is also the short form of the spark ignition is SI, and the compression ignition is CI. Okay. According to the cooling system, air cooled system, water cooled, air cooled engine, and the water cooled engine, two types. Valve location, according to the valve location, L head engine, T head, I head, and F head, four types of engine. So we can classify or we can divide the IC engine based on these six parameters, that is the cycle of operation, thermodynamics, type of fuel use, ignition method, cooling system, and the valve location. Okay. So again, I told you regarding the cycle operation, there are two types: 2-stroke, 4-stroke. The method of heat addition: Otto cycle, diesel cycle, and semi-diesel cycle. Fuel used, according to the fuel use: petrol engine, diesel engine, gas engine. According to the ignition method: spark ignition, compression ignition. According to the cooling system, air cooled engine and water cooled engine. According to the valve location, L head, T head, I head, F head. Basically, in your syllabus, basically you have to know the two-stroke, four-stroke engines, this SI, spark ignition, compression ignition, and some part of the petrol, diesel, and the gas engine. Okay. So before going to the other parts, if we want to see the terminology of this IC engine, so this is a basic, you can say a block diagram or basic simple diagram of IC engine. So the first is the standard term used in the IC engineer. First one is the bore. So bore means inside diameter of the cylinder is termed as bore. Inside diameter means, if you see in that picture, this is the cylinder, and so this is the inside diameter of the cylinder. So this diameter is known as the bore. Okay. Second is top dead center, also known as the TDC, top dead center. The extreme position reached by the piston at the top of the cylinder in the vertical engine is called the top dead center. So if you see in the diagram, this is the piston. Okay. So this, there is a limit of the piston to go upward. Okay, after that, here is the top dead center, you can see TDC in that point. That means after that, that piston will not able to go. This is the last limit or the maximum limit of the piston can reach inside the cylinder. So this is known as the top dead center. Okay, that's why it is written the extreme position reached by the piston at the top of the cylinder in the vertical engine is called the top dead center. Okay, similarly, the bottom dead center, the extreme position reached by the piston at the bottom of the cylinder is called the bottom dead center. So similar, if the piston can able to go up to that point at the bottom of the cylinder and it is not able to go further down, then this point is known as the bottom dead center. After that, it is not able to go down. Okay, so this point is known as the bottom dead center. Next is the stroke. The nominal distance traveled by the piston in the cylinder between the extreme upper and the lower position of the piston, that means TDC and BDC, is termed as stroke. The nominal distance traveled by the piston in the cylinder between the TDC and BDC. That means this TDC is at that point and the BDC is that point, so that piston can move within this bottom dead center and top dead center due to the influence of the gas. So this distance is known as the stroke. You can see here it is given, this distance is known as the stroke. That means that piston can travel the distance in between the bottom dead center to the up to the top dead center. So this distance is known as the stroke. Okay. Compression ratio, it is the ratio of the maximum cylinder volume to the clearance volume. Okay, so clearance volume means maximum cylinder volume means the original cylinder volume, that means the volume of the cylinder, and the clearance volume is that one, that means the clearance volume is the volume which is after the top dead center. Okay, so you can see this is the top dead center, that piston cannot go above the top dead center, and there is a place where this piston cannot go or move. So this volume is known as the clearance volume, and the volume of the total the engine total engine volume is the maximum cylinder volume. So the ratio of the maximum cylinder volume to the clearance volume is the ratio, is the compression ratio. This ratio is known as the compression ratio R. Okay, cylinder volume is the sum of the swept volume and the clearance volume. So as I told you, the cylinder volume means that it is not the total cylinder volume which is written here maximum cylinder volume. Cylinder volume means swept volume and clearance volume. So what is swept volume? This is the clearance volume. So when the IC engine is working under the influence of any gas, hot gases, so due to the pressure or the force of the gas, this piston is moving in between the bottom dead center and the top dead center. So we can expect that at the time of the moving, that piston can go slightly further up or can go slightly further down. So this slightly further up and slightly further down, these volumes are known as the swept volume. Okay, so the clearance volume plus the swept volume is known as the cylinder volume. Okay, so that means V is equal to the swept volume plus the clearance volume. So we know that the clearance volume, but how we can get the swept volume? When the machine is or the engine is running, the piston is moving. So at that time we have to check that when the piston go to the top dead center, how much it can go above the top dead center, and how much it can go down below that bottom dead center. So if we add these two, then we can get the swept volume, and if we add the clearance volume with the swept volume, then we can get the cylinder volume. Okay, so the compression ratio is the maximum cylinder volume to the clearance volume. That means cylinder volume means clearance volume plus swept volume divided by the clearance volume. Okay, so if we again simplified it, so in the numerator it is swept volume plus clearance volume, that means Vs plus Vc divided by Vc. So we can say the compression ratio R also can be 1 plus swept volume by the swept volume by the clearance volume. Okay, so this is also the compression ratio, 1 plus swept volume by clearance volume. Okay, next is the swept volume. It is the volume of the space generated by the movement of the piston from one end center to the another dead center. Okay, so this is the volume what I told you. And the clearance volume is the space in the cylinder when the piston is at the top dead center. So as I told you, so this is the clearance volume and the swept volume also. So these are the basic terminology of the IC engine. That means bore, top dead center. Bore means the diameter of the cylinder. Top dead center is the position up to which the piston can move. Okay, the bottom dead center is the extreme below position, below which point the piston cannot able to move. The stroke is the distance between the TDC and the BDC. Compression ratio is the cylinder volume by the clearance volume, or you can say that the 1 plus swept volume by the clearance volume. Cylinder volume is the swept volume plus clearance volume. Swept volume is the volume space generated, and the clearance volume is the volume above the top dead center. So this is the basic terminology of the IC engine. So basically this is a schematic of IC engine. In the schematic you can see that here is a spark plug, the valve spring, cam, mixture in, mixture out, exhaust valve, intake valve, combustion chamber. That means this is the combustion chamber. That means this is also the clearance volume. That means inside the clearance volume the combustion take place. This is the cylindrical block, connecting rod of the piston, crankshaft due to which the piston is able to move. The crankcase is there. This is the piston, cooling water for the cooling purpose of the engine, cylinder head, and exhaust valve, as I told you. So these are the basic things of the IC engines, and here is the basic component of IC engine. What I told you, that cylindrical block, cylinder, piston, combustion chamber, inlet manifold, exhaust manifold, inlet exhaust valve, spark plug, connecting rock, camshaft, piston ring, mm, guardian pin, and the camshaft. So here you can see that cylindrical block is there. This is the cylindrical block. This is the cylinder. This is the piston. This is the combustion chamber. Okay. Inlet. This is the inlet. This is the exhaust. Inlet exhaust valves are there. Sparking plug is there. Connecting rod is there. Crankshaft is there. Piston ring is also there. Okay. Guardian pin is also there. Camshaft is also there. Okay, so these are the basic component of IC engine. So as we start today the IC engine, I do not go further because next class we have to we have to know the very detail of the two stroke, four stroke, how the operating take place, how the piston is moving, how the combustion take place inside the piston. Okay, so all these things you have to know in detail. So for today's class I do not go further. So after this, if you have any problem you can ask me.
Sir, where does the fuel burn, sir, in engine?
Where does
Hello,
the
sir.
fuel burn in the engine? So
Sir,
inside
yes,
the
sir.
combustion chamber, you see this is the combustion chamber.
Yes,
This
sir.
is the intake. That means with the help of the intake we give the air and fuel inside this combustion chamber.
Oh,
And inside this combustion chamber the combustion take place. How this combustion take place? There is a spark plug. This
yes,
plug
sir.
will to take combustion in proper manner. Okay.
Yes, sir. Yes,
So
sir.
basically inside this combustion chamber the combustion take place and the gaseous product is generated, and due
Okay.
to
Sir,
this
so actually it means that above the piston, sir.
above the
Top,
piston.
top of the piston.
Yeah, above the top dead center of the piston. Okay,
Okay, sir. Okay, sir.
so inside that, and due to the as the gas is generated,
Yes,
then
sir.
so the heat energy also generated, and due to this energy and
Yes,
the
sir.
force of this gas, this
Yes,
piston
sir.
is start moving. Okay, so
Okay,
how
sir.
all these things happen, how this combustion take place, how after the combustion the piston is running, and how it
Yes,
is
sir.
operated, everything we will have to discuss and we'll
Okay,
have to
sir.
know in detail. Okay,
Okay, sir. Okay, sir.
anything else?
No, sir.
Anybody? Okay, so please switch on your video so that I take a snapshot.